number 3 completely on your own. You're on number 5. Thank you. Keep in mind, if you see multiplication or division in the integrand, you cannot move forward. You have to get rid of the multiplication. So the key here, distribute. So if I'm going to distribute, I need to see that there's still a definite integral. E to the 3x multiplied with e to the 3x. It's going to be e to the 6x minus e to the 3x times e to the negative 3x. The bases are the same. The rule here, add the exponents. So you're going to get e to the, what, 0? E to the 0 is really 1. Finish up. You got to take care of the algebra before you can move into the calculus part. As long as you know you're going backwards. My question
And 1/6 plus 1/6 to the 12. So plug in 0. Isn't it what you get? You get the derivative. That's the derivative. And then oh.
Okay, I'm seeing a lot of folks make some good progress on this. The antiderivative is 1/6 e to the 6x, ooh, ugliness, minus x, and that's when you find the antiderivative, that's when you replace the definite integral with the evaluation notation. Your next move?
Evaluate.
We're going to evaluate. We're going to plug in. You always plug the top one in first. Big mistake that I see a lot of folks making is they're not using parentheses well. If x equals 2, so I've got 1/6 e to the 12 minus 2, great, minus, what do I get when I plug in 0? Not 0,
No.
1/6 e to the 0 minus 0.
Negative
1/6.
1/6.
Right, so this is 1/6 e to the 12 minus 2. E to the 0 is 1. Times 1/6 is 1/6. So it's minus 1/6. And depending on the problem, maybe you need to get a common denominator here. Negative 2, same thing as negative 2 over 1. Negative 12 over 6 and negative 1 over 6 is negative 13 over 6. If it's free response, I'll take this one, or I'll take this one. How many guys made it all the way over to here? Okay. All right, show me what you can do at number 2. Number 2, 1 minute, completely going solo. All right, the friendly nudge before a little bit of work time here. If I'm going to get rid of this division, I would go from 1 fraction over to 2 fractions. Is that legal?
Mm-hmm.
Okay, now the question is that better?
Yes.
If it's better, somebody tell me why it's better. Why is it better? What can you do now that you couldn't do before? Jonathan, what can you do now that you couldn't do before?
Take out T.
What do you mean take out the t? So I'm afraid you see a t up here and a t down here and you're like, get rid of them. This is, right, t is t to the 1. Rather than square root of t, I could also write this as t to the half. T to the first divided by t to the half. Oh, so quiet. T to the first power divided by t to the half power is t to the... If you're dividing and the bases are the same, the rule is... My goodness. Okay, let's pull out a calculus just for a second here. I know every single one of you knows what the answer to this is. It is not possible that you don't know. X to the 8th divided by x to the 3rd is? X to the 5th power. Jasmine, why is it x to the 5th? What did you do to get x to the 5th?
You subtract the exponent.
You subtracted the exponents here, right? So you said, oh, x to the 8 minus x to the 3rd. You probably didn't write it down this way, but you subtracted the exponent and get x to the 5th? Same thing. T to the 1st divided by t to the half. The rule is? Subtract the exponents. T to the 1st divided by t to the half. Subtract those exponents. T to the half. Instead of 1 over the square root of t, I can write this as t to the negative 1/2. Finish it off.
Square root.
So antiderivative of t to the 1/2, that's fitting this x to a power form. Right, it's the power rule. Power rule says add 1 to the power, so t to the 1/2, add 1 to that power, t to the 3/2. Divide by the new power, 2/3. Same thing over here, add 1 to the power. What's the new exponent? My original exponent is negative 1/2. Add 1 to the power. Negative 1/2 plus 1? 1/2. 1 divided by 1/2 is 2. Now evaluate from 1 to 16. Honestly, how many of you guys had the antiderivative part right? Okay. Next move.
Evaluate.
David, what are you going to do? You're going to evaluate, right? You just have to plug this in. So you've got 2/3 times 16 to the 3/2 plus 2 times 16 to the 1/2. I want to see big parentheses there because it's this next place where the parentheses are essential. Plug in 16 minus plug in 1. So 2/3 times 1 to the 3/2 plus 2 times 1 to the 1/2. Getting here on the free response, you're done. But a question like this can show up in the multiple choice, and so you need to know how to handle all the exponents. 16 to the 3/2, you guys know the 2 tells you to take
Square root.
square root. So square root of 16 is 4, and then the 3 means cube it. So square root of 16 is 4, 4 cubed is 64. Now you got to do 2/3 of 64, 128 over 3. 16 to the 1/2, square root of 16. 4 times 2, 8. All that minus all the stuff that comes after. 1 to the 3/2 has to be 1. Times 2/3 is 2/3. 1 to the 1/2 is 1 times 2. Now you could get a common denominator here if you want to. Get a common denominator here if you want to. Or you could be a little bit clever. I see a fraction in terms of thirds over here, minus a fraction in terms of thirds over here. 128 thirds minus 2/3 is 126 thirds, and 126 divided by 3 is... I swear you guys can do that. 42. Plus 8 minus 2, 6. Grand total, 48. Tonight's homework is just going to be to get some more practice with problems with this. Marcia, don't worry, we still have 15 whole minutes left. Marcia, your head angry, like you looked at the clock and you're like, what are you going to do for the next 15 minutes, coach? I'll tell you what we're going to do. We're going to go to the world of application problems. Oh, so exciting. Thank you for not moaning at me. I do appreciate it. If I had a heart, I'd get upset with something like that. Here comes the good news. It is time to power up your skills. My goal in the next 15 minutes is that we are going to set up at least 3 of these.
Mr. D.
Yes, sir.
You forgot to dismiss other table.
I forgot to dismiss the other table. I thought I had said that once this table went, David's table went, then Daisy's table went, then their table went. I'm worried about closing the achievement gap. I figured you guys would follow the pattern. And I said after Rambir's table, David's table would go, and then Daisy's table would go, and then that table. See, the problem is not listening. If you guys don't mind, I'm going to go back to closing the achievement gap while you all figure out a nice, orderly way to go get your stickers. Yes, that's exactly what I just said. God have mercy. All right. We're going to the land of the application problems. Life is good. What secretly is happening right now, you are going to get some review time of all the important skills. So let's look at problem number 2. Problem number 2, a car travels with a velocity given by v of t equals t squared minus 1 over t kilometers per minute for t greater than or equal to 1. At time t equals 1, the car's position is x of 1 is equal to 3. Determine the displacement of the car from t equals 1 to t equals e minutes. Why don't you have a strategy conversation with somebody near you? What are you going to do? Problem number 2.
Or if you want to find the displacement, you have to find
Yeah.
because you have to lost one.
Oh yeah.
Stop saying absolute
Because
value.
like if it,
Yeah, that's
Well, no, displacement. That's only total distance. That's total distance. Displacement.
derivative.
yeah. That's what I'm saying.
Yes, if you're going to use this, please use the right version.
Just natural log. No one feels
Want me to do
Well,
something?
they had weird.
I do.
I get it for 1.
Yeah, you just said
All right, Edgar, friendly reminder for everybody, how do we find displacement? If you're given velocity, how do you find displacement?
You take the antiderivative of the velocity.
So you need the antiderivative of the velocity from where to where? From where to where?
From t equals 1 to t.
I want the displacement from 1 to e. I swear, if we're talking about like free response, you're on the board. You've got the first point because you wrote down the right thing. And so now it's just a matter of what's the antiderivative of 1 over e of t squared minus 1 over t dt. 30 seconds on your own. You'll get the antiderivative when I'm talking. If you need to pull out the flashcards, pull out the flashcards. Because the next point comes from, can you get the right antiderivative? If you feel good with that, keep going. I've seen that on about 8 different papers. Antiderivative of t squared is 1/3 t cubed minus the antiderivative of 1 over t. Natural log of the absolute value of t. How many guys had that as your antiderivative? Nice. 1 point for having the right setup. The next point for finding the antiderivative. And then you guys know exactly what to do next.
Evaluate.
You're just going to evaluate, right? So plug in.
Let's see. Let's see.
And be careful. Plug in the e. I've got 1/3 e
It's
cubed
so cute.
minus the natural log of the absolute value of e minus big parentheses. I cannot overemphasize these big parentheses. Without them, you're going to get confused with the negative sign. So 1/3 of 1 cubed minus the natural log of 1. There is some simplifying I want everybody to be able to do. What's some legal simplifying we can do? I'll take anything from anybody. Legal simplifying. Jasmine, what could you do?
1/3 times 1 to the cube is just 1/3.
Okay, so we've got 1/3 over here. We can simplify that a little bit. What else? I'll take anything from anybody. One, what else?
Natural log of. Never mind.
Oh, I thought you had it. You're sitting so close to the poster.
Oh, it's 1.
It's zero.
It's 0.
Which one are you talking about, Juan? The natural log of 1 is 0. I was hoping somebody else was going to tell me about the natural log of e. They were going to tell me that the natural log of e is 1.
Oh no.
Okay, now don't blow it with the simplifying. 1/3 e cubed minus 1 minus 1/3. Please don't mess it up with the simplifying here. 1/3 e cubed minus 1 minus 1/3.
Oh, the 1 and the 1/3. No, the 1 and the 1/3.
Sorry, I had a heart attack there.
No, don't say that.
-1 minus 1/3. -3/3 minus 1/3 is going to be -4/3. Now, depending on the problem, that might not be the best final answer. Somebody tell me why. What's wrong? What's wrong with this final answer? Giselle, what's no way know about this?
Units. We're missing
You need
units.
units. What are the units supposed to be?
Kilometers.
They're gonna have to be. Okay. So if I'm thinking about how I'm gonna score it, 1 point for the right setup, 1 point for the integrand, probably 1 point for knowing to evaluate and getting this in the right order with the big parentheses there, and maybe another 1 point for simplifying and getting the units. All right, show me what you guys can do at number 3. We'll talk in a little bit. I know that's not an answer that you like, but getting the right setup gets you the first point. Let's do about 5 people who get the first point. Make that 6 people. 7.
8.
Teens. Oh, thank you. 8. Oh yeah, you too. All right, for the function f of x equals sine pi x over 4, determine the area bounded by the curve and the x-axis. Great. Sine pi x over 4 dx from -2 to 2. Getting that set up, first point. First point rains down from the sky. Now the question is, what's the antiderivative of sine pi x over 4?
No, 1 over.
And I'll tell you, usually it's the angle that messes everybody up. I heard just like from just about everybody, negative cosine.
No, 1 over.
Negative pi.
But hold on, that because you're finding the antiderivative of sine, it must be a negative cosine. But then you've got to figure out what's the k. A better way to write pi times x over 4 is pi over 4 times x. That means that this is the k. So it looks like Jasmine's got this one right. So it's going to be the negative of 1 over k cosine pi over 4 times x, but k is pi over 4. So -1 divided by pi over 4 cosine pi over 4x from -2 to 2. If you don't like writing negative of 1 divided by pi over 4, great, do something better.
-4 over pi.
Do a little keep it, change it, flip it. So you've got -4 over pi cosine pi over 4x from -2 to 2. How many of you guys honestly had that as your antiderivative? This one or that one? Either one, doesn't matter. Okay, it looks like we're in a pretty good place. And so then it's just a matter of plug in -4 over pi cosine pi over 4 times 2. Pi over 4 times 2 is the same thing as
Pi over 2.
2 pi over 4, which is the same thing as pi over 2. Minus, now plug in the -2. -4 over pi cosine pi over 4 times -2 is negative pi over 2. Cosine of pi over 2. Think about that unit circle, cosine of pi over 2.
0.
Cosine of pi over 2 is
0.
0. What a happy number to see. 0 times -4 over pi? 0. Minus a negative, so I've got plus cosine of negative pi over 2. Avoid the temptation to say -0. Good. Thanks for the pity laugh. 0 for sure. 1 point for the setup. At least 1 point for the integration. 1 point for the evaluation. Okay, let's end this with a bang. Problem number 4. Show me what you got. I didn't give you any units in this problem.
Secant is just tangent. No. 10 times secant.
I need to see the work, Jonathan. Yes, you're right. The antiderivative of secant of x times tangent of x is secant of x, but I don't care. I need you to follow Jose's example. Wow. I can count the number of times I've said that this year. I need to see the work. That's not the way I would set it up. No. Okay. Just a little side note for those of you that don't remember how to find average value. It's the integral from a to b of the function divided by the length of the interval. So in this case, you're saying it's the antiderivative of secant of x tangent of x dx from 0 to pi over 4, and I've seen this on a whole lot of papers. But you need average value, so stay with me for a second, divided by pi over 4 minus 0. Pi over 4 minus 0 is really pi over 4, but Jose, because you're dividing by pi over 4, that's the same thing as multiplying by 4 over pi. Okay, and just real quick before you guys run on out, antiderivative of secant of x times tangent of x has to be secant of x. So your final answer is going to be whatever you get when you finish off the integral 4 over pi secant of x from 0 to pi over 4, whatever you get when you simplify. Not worried about that. Tonight's homework is just the last 8 problems. Some of them are straightforward, others